So here in this section, we're going to talk about how to evaluate infinite limits. How do we determine if a limit is approaching positive infinity or negative infinity based on just the equation, just using algebra here. So I have a limit here. I'm looking at x minus 4 over x plus 2. I'm going to look at the left-hand limit, the right-hand limit, and then the two-sided limit. And if you're ever not sure where to start, my suggestion to you is always just to take that number and plug it in, and we'll see where it gets us. If we end up with a finite value, that's kind of the best case result, and that means that that's our answer, and that's it, we're done. But if we end up with something that's not finite, worst case scenario, we'll still gain a little bit more insight as to what our function might look like. We might understand the behavior at that x value a little bit more. So here I'm going to take negative 2, plug this into my function. Negative 2 minus 4 divided by negative 2 plus 2. Here I have negative 6 divided by 0. From this last video, or from the last video, I can tell that the denominator is 0, that the numerator is not, which tells me that we have a vertical asymptote at x equals negative 2. So I need to think about a different way to approach this. And if you think about what's going on here, when we have a vertical asymptote, and we're just going to stick to rational functions for right now. When we're dealing with a rational function, let me draw out what's going on here. Oops, let's make that a little bit better. There we go. 1, 2. So we have a vertical asymptote right here. And if I'm looking at a rational function, that means that the one-sided limit, the left or the right-hand limit, is either going to be positive infinity or negative infinity. And I don't really have a great way for right now to determine which one it is. So what I'm going to do is I'm going to pick a number, because we're looking at the left-hand limit here. I'm going to pick a number that's very close to negative 2 on the left-hand side. So negative 3, I'm going to tell you right now, it's too far away. It won't work. It might work for this particular problem, but there are other problems in which, it actually would not work for us. So I'm going to say negative 3 too far away. You generally want to be within one decimal place. So you might pick, say, right here, maybe negative 2.5, or you could even move a little bit closer. I like to use negative 2.1 as a number that's very close to negative 2 on the left-hand side. And what I want to do with that number is I'm now going to take that number, I'm going to plug that into this function over here and see, does it give me a positive number or does it give me a negative number? Because I know it has to approach either positive infinity or negative infinity. I just need to figure out which one it is. So I'm going to choose x equals negative 2.1. I'm going to plug this into my function, and I'm going to determine whether or not I have a positive number or a negative number. So here I'll have negative 2.1 minus 4 divided by negative 2.1 plus 2. Now, I'm not so much worried about the actual value of the number. You could go and calculate that number if you really, really wanted to. I'm mostly just interested in what sign does this number have. Is it going to come out as a positive number or a negative number? Because then that'll tell me, are we approaching positive infinity or negative infinity? So most of the time, I won't even do the calculations. I'll just say, hey, I have a negative number minus a negative number. I know that's going to give me another negative number. And I'm just going to denote that in my numerator. In my denominator, I have a negative number plus a positive. Here, in this case, 2.1 is larger, which means that I'm going to end up with another negative number. And here I have a negative divided by a negative. I know that if I take two negatives, divide them, I will end up with a positive number. So I know at the end of all this, I don't necessarily know what the number is, and to be honest, I don't really care. I really just care about the sign of that number. Will it be positive or will it be negative? Here, in this case, because we ended up with a positive number, because we have this right here, we can then say that our limit must be positive infinity here. So for part B, it's the same function, same story. We're just looking at the right-hand side now, and we're going to take a very similar approach. If I was just starting this problem out, again, I always encourage you to take that number and plug that in. One thing I'll note here is that this method only works if you have a vertical asymptote. If you do not have a vertical asymptote, none of these methods are going to work or make any sense here. It only works if you have a vertical asymptote. So it's really, really important to show that you actually have a vertical asymptote before you jump into using this method. So anyway, I know that there's a vertical asymptote here. I'm going to pick a number again that's very close to -2 on the right-hand side this time. So again, -1 or 0 over here, those are too far away. I'm going to pick something very close. In this case, I might pick -1.9 and plug that in. So if I take x equals -1.9 and plug this into my function, -1.9 minus 4 divided by -1.9 plus 2. Here in my numerator, I've got a negative minus negative. I know that will give me a negative number. Divided by negative plus a positive. Here in this case, 2 is bigger, so I should end up with a positive number here. And I have a negative number divided by a positive number. If I divide those two, I know I'll end up with a negative number, which means that my solution, my answer, should be, not positive infinity, negative infinity. Because I had a negative result. Because this number turns out negative, that's what allowed me to say that my limit is negative infinity. Part C is just asking for the two-sided limit here, and for this I can just look at my results for parts A and B. For the left-handed limit, I had positive infinity. The right-handed limit, I had negative infinity. So the only thing we can really say in this case is that this limit does not exist because the two one-sided limits do not agree. So I'd like to take a look at one more example here. This one's a fair bit more complicated, so we'll take our time through this. But here I have limit as t approaches 1, I have t cubed minus 5t squared plus 6t divided by t to the fourth minus t squared. Oh boy, okay, lots happening there. So again, my suggestion to you, if you're not sure where to start, just take that number and plug it in and see where it takes us. So I'm going to take 1 and plug this in. So let's see, I'll have 1 cubed minus 5 times 1 squared plus 6 times 1 divided by here, I'm going to have 1 to the fourth minus 1 squared. 1's a pretty nice number to work with here. Let's see, I'll have 1 minus 5 plus 6 divided by 1 minus 1. Here I should have, let's see, 1 minus 5 would be -4 plus 6. I've got 2 divided by 0. So I don't have an answer, but I do know that I have a vertical asymptote that's occurring here. Which means that because we're working with a two-sided limit, I am going to want to break this down and look at the left-hand limit and the right-hand limit. Before we do this, though, before we jump into that, I would actually try and take this original function, because I'm going to want to pull the same trick. I'm going to use the same methods I was just earlier, but this is a really complicated looking function. And generally it becomes much, much easier to use that method if you have very small bite-sized pieces. So I'm actually just going to take this and see if I can factor it. So in my numerator, I can factor out a t. So actually, let's do this. Let's just give myself a little bit of separation here. So I'm first going to factor out a t. That would leave me with t squared minus 5t plus 6. Divided by, in my denominator, I have t squared. I can factor that out. That'll leave me with t squared minus 1. And then at this point as well, if you wanted to reduce these t and t, we actually could go ahead and do that. And then I can actually factor this a little bit further. In my numerator, two numbers that multiply to be positive 6 add to be -5. That would be t minus 2 times t minus 3. In my denominator, I still have a t, but t squared minus 1, that's a difference of 2 squares. Here I could take t plus 1 times t minus 1 here. So this is actually going to be, this form is going to be a lot easier for us to work with and apply that method that we were just using earlier in parts A and B here. So let's start with the left-hand limit first. That's just what I picked. So the limit as x approaches 1 from the left-hand side of my function, I'm just going to call it f of x here. And again, to show that work here, I might pick a number that's close to 1 on the left-hand side. If you're struggling to determine numbers that are close to it, draw out a number line here. So here we've got 0, we've got 1, we've got 2. So a number that's close to 1 on the left-hand side, I might be thinking about maybe 0.9, I think would be a really good choice here. So I'm going to take x equals 0.9. I'm going to plug this into this factored form over here, this factored form right here, and determine just, do I get a positive number or a negative number? And here especially it becomes a lot easier to just look at the sign. Let's not worry about the calculations. All I'm going to care about is the sign. So let's see, I have 0.9 minus 2 times 0.9 minus 3 divided by 0.9 times 0.9 plus 1 times 0.9 minus 1. And in each one of these factors now, I can just look at positive number or negative number. What kind of number do I have? Because that's really, again, all I care about. So 0.9 minus 2, that's going to be a negative number. 0.9 minus 3, this piece right here, well, that's going to be another negative number. Divided by, in my denominator, 0.9, that's positive. 0.9 plus 1, that's going to be another positive. And 0.9 minus 1, I know that's going to be a negative. So I'm going to simplify my numerator and my denominator here. If I just look at my numerator here, negative times a negative gives me a positive. And if I just look at my denominator here, positive times positive would be positive. Times negative, I've got a negative number. Divide these two, I get a negative number. Which means that when it comes to talking about this left-handed limit over here, this must be negative infinity. So I've talked about the left-hand side. Now I'm going to do the same thing for the right-hand side over here. And so, again, if you pick 2, I think it's going to be too far away. In particular, if you kind of look at what would happen if you took 2 and plugged it in, you'd actually get 0 right here, which in that case, 0 is neither positive nor negative. It doesn't actually give you any information here. So you want to be very, very clear with your choice. You want to get as close to that number, in this case as close to 1 as you can. So here in this case, let's use a different color here. Let's do, I don't want to, oops, I'm kind of running out of room here. So let's say this right here. Limit as x approaches 1 from the right of f of x. You know what, I just realized I'm mixing my x's and my t's. It happens to all of us. Just to show you, I'm not going to worry about it here. So here I'm going to think about a number that's close to 1 on the right-hand side, and I'm going to do this work down here. Here, how about x equals 1.1, I think would be a good choice. So here, 1.1 minus 2 times 1.1 minus 3 divided by 1.1 times 1.1 plus 1 times 1.1 minus 1. Again, I'm just checking the signs here, positive or negative. 1.1 minus 2, that's going to be a negative number. 1.1 minus 3, that's going to be another negative number. Denominator 1.1, that's positive. 1.1 plus 1, that is also going to be positive. And 1.1 minus 1, that is also going to be positive. So in my numerator, I have negative times negative. This is negative. Divided by my denominator, positive times positive times positive will be positive. Here I have negative divided by positive. Whoops, you know what? I made a silly mistake here. Negative times negative, this should be positive. You were probably yelling at your computer at home. I'm sorry about that. Negative times negative gives positive. Here, positive divided by a positive would give me a positive number, which means that this limit should approach positive infinity here. All right, so we're pretty much done with this problem. I've looked at the left-hand limit. I've looked at the right-hand limit. They are not the same, right? One is negative infinity, one is positive infinity. So if I wanted to talk about the two-sided limit, kind of running out of room, but I'll just do it right here. I'll say limit as x approaches 1 of f of x, then in this case does not exist because the left and the right hand limits approach different values.